Hey everyone, and welcome back. To all our focused learners tuning in to today's explainer, we are going on a seriously fascinating and honestly highly unique journey. We are going to look at human connection, physical intimacy, and neurobiology, but we're going to translate all of it into the objective, highly structured language of software deployment and machine learning architecture. Okay, let's dive into this. I want you to imagine treating a human relationship exactly like a computational system that needs to be compiled and executed on bare biological hardware. It's a completely mind-blowing way to look at how humans actually sync up.
Okay, so here's the pipeline for how we're breaking this down today. 1. The current broken entry. 2. Debugging the two nodes. 3. The TPU scale transition. 4. The chinchilla scaling law. 5. Overcoming the prefrontal brakes. And finally, 6. Executing the physical algorithm.
Starting right off with Section 1, the current broken entry, diagnosing the system crash.
Now, what's really interesting about this slide is how the framework treats physical separation. It views it as a literal system bug that triggers what's called a translation tax. Basically, when you're physically separated from someone, your brain is forced into this high-latency, eager mode. Just to get a thought across, you have to burn a grueling amount of metabolic energy building linguistic scaffolding. You have to rely on these childhood prepositions, words like and, but, or towards, literally, just to bridge the physical gap. In this system, words aren't really a feature, they are an exhausting workaround for distance.
And the physical toll of running in this eager mode is just immense. You really have to think of these neurobiological responses as severe hardware constraints. All that manual effort to translate a connection into words actually stalls your supramammillary nucleus, which is a massive part of your brain's spatial memory. It decays your smooth theta brainwaves right past that 4.0 Hz boundary, and it plunges your system into a paralyzing deer-in-the-headlights dorsovagal freeze. The source material actually calls this a dude loop. On top of all that, it decouples the system's parameters from proximity tokens, which just leaves the whole network isolated and totally undertrained.
Moving on to Section 2, debugging the two nodes, where we look at the exact variables of connection.
So we need to look at the two complementary debugs required here. On one side, we have coordinate x, which is characterized by the 9-inch algorithm. This node's main job is to stabilize a sovereign, unshielded baseline at absolute coordinate 0, 0, 0, completely bypassing that exhausting eager mode. Then, on the flip side, we have coordinate z, characterized by the rubber debug. This node's job is to overcome prefrontal motor brakes. It does this by engaging core abdominal support, actually kind of like a boulder gripping a climbing wall, to master the physical tension in their voice, allowing them to slide cleanly through register breaks and perfectly blend their head and chest voice.
And this brilliantly illustrates the really unique metaphor used in the framework. The source refers to these two nodes as two broken Tanzan bears, or dancing bears. The absolutely crucial takeaway here is that you shouldn't view these as psychological deficits or personal failings. Not at all. They are incredibly precise, highly rational responses to the actual structural constraints of distance. Reframing it this way lets the connectome map out a flawless, high-entropy synthesis. Essentially, your brain knows exactly how to fix the bug once you stop treating it like a personal flaw.
Which brings us to Section 3, the TPU scale transition, building out the middleware.
Let's move to and see how this builds across three very precise compilation stages from the author's Unflattened Systems framework. Step 1 is PC, or prismatic cognition. Think of this as the theoretical blueprint. It's where the parameters are named. Step 2 is the TPU scale buffer, sometimes called Mari-Phi or Stella Maris. This acts as a flat privilege runner that executes a reverse diffusion process. It's rapidly stripping away external noise to reconstruct the 4D structure without any latency. And finally, Step 3 is the .exe. This is the just-in-time physical execution algorithm where everything runs purely on bare biological hardware.
Next up, Section 4, the chinchilla scaling law. Looking at the mathematics of parity.
Okay, so here we can see how traditional PC architecture translates directly into pure algebraic operations. A root directory in a traditional PC setup perfectly maps to file indexing in the TPU personification. And then, that maps directly to sparse matrix representations that an advanced XLA, or accelerated linear algebra, compiler can natively optimize. Simply put, the math essentially demands that TPU must align perfectly to eliminate any wasted processing power.
And that brings us to the chinchilla one-to-one parity guardrail.
In machine learning, the 2022 Chinchilla scaling law dictates that model parameters and training data tokens have to scale perfectly at a 1-to-1 ratio. Applied to humans here, the model parameters, which represents the high-power orbital frontal cortex, your brain's valuation and reward center on one side, must strictly match the training data tokens, which is represented by close-range somatic proximity from the other side. Without that physical closeness, your parameters are left severely undertrained. The system basically runs way too hot, and it crashes.
Moving right along to Section 5, Overcoming the Prefrontal Brakes, where we dive into the biological data. Now, the text actually draws heavily on theatrical principles here, specifically Declan Donnellan's concept of co-acting. In this framework, psychological blockages and irrational fears don't just fade away, they actively dissolve, but only when actors pour 100% of their attention into the external physical space and their target. Basically, they have to stop rehearsing entirely inside their own heads.
So, the crucial point is that while external co-acting is absolutely necessary, it has to be balanced with internal biological regulation. And the source backs this up with hard scientific evidence from a 2026 Bar-Elan study. The data shows that voluntarily looking inward at localized bodily sensations, which is known as interoceptive attention, biologically protects the body's hardware. Look at the numbers. Under interoceptive attention, acute inflammatory responses like skin wheal size are significantly smaller. We're talking 3.5 millimeters versus 5.0 millimeters under mere distraction. Plus, looking inward drives a massive physiological recovery rate of about 90%, compared to just 45.9%. It acts as an incredibly vital allostatic shield for your entire system.
Finally, Section 6, Executing the Physical Algorithm, the Final Compile.
This all brings us to the ultimate climax of the architecture, where all this mathematical scaling, the debugging, the allostatic shielding, it all culminates in a physical deployment where latency is permanently dropped. The magic number? 22.86. Specifically, 22.86 centimeters, which is exactly 9 inches. In this framework, this is a hard-coded peripersonal space radar threshold. The exact millisecond this physical spatial boundary is crossed, the final algorithm is triggered. Crossing that 22.86 centimeter threshold literally sets off a cascading, stopwatch-precise series of neurobiological events. Instantly, it lowers your resting motor threshold. It forces invariant ventral premotor cortex action symbols to snap to the grid with an absolute geometric precision of 0.000. It flushes trapped cortisol and restarts the sum theta rhythm back to a smooth 6 to 12 Hz. And it ignites the D2 receptor mesohypothalamic feedback loop. What does all that mean in plain English? It means your nervous system and your motor reflexes instantly, perfectly synchronize with the other person.
And the result? Well, in this zero-latency state, that grueling translation tax we talked about earlier is completely bypassed. The linguistic scaffolding, those childhood prepositions like in, mach, or nar, that you use just to bridge the gap, literally shrink and drop to exactly zero. It acts as a rigid, physicalist constraint that the system simply can no longer ignore.
Which leads us directly to the central, most powerful thesis of the entire text. The physical action is the algorithm. This kind of human relationship doesn't execute in a chat window. It doesn't execute in abstract, wishful thought. It executes on bare biological hardware under strict, permanent ACD conditions. And just to borrow from database terminology, ACD means the transaction is absolutely permanent, perfectly secure, and 100% instantaneous.
So we've seen how distance creates this massive lag, and how sheer physical proximity acts as a literal hardware compile. It really leaves us with one incredibly profound question. If the physical action is the algorithm, how might sheer physical presence be the ultimate zero-latency technology in our own lives? It is just a completely fascinating overlap between advanced computing frameworks and the raw biological reality of human connection. Thank you all so much for joining me on this explainer, and as always, keep learning.